Welcome and good day everyone. So here is the solution process for SOAP or physics exercise chapter 7 gravitation. Alright, so there are set 3 subtopics here: gravitational force and field strength, gravitational potential energy, and satellite motion in circular orbit. Alright, so we go to question number 1. Okay, so the question is 1,000 kilogram is in orbit 350 kilometer above the Earth's surface. Okay, so mass given is 100,000 kilogram. Okay, so question cakap apa tadi? Question cakap orbit H. Okay, so H is 350 kilometer above the Earth's surface. Okay, so kat sini kita tahu. Okay, ini contoh is object. Alright, so this is H. H is altitude 350 kilometer above the surface. This is your radius of Earth. So our R is equal to R Earth plus H. Okay, remember that R is always measured from the center of the Earth. Okay, given that the radius of Earth is 6.4 times 10 power of 6 meter, and the mass of Earth is 6 times 10 power of 24 kilograms. Okay, so you have to find the speed of satellite. Speed of satellite. Okay, so macam mana nak cari speed of satellite? Contoh macam kata saya tak tahu macam mana. Contoh tak tahu dia punya formula, so kita nak derive sikit. So summation FC equal to mv squared over r. Okay, walaupun V diberi kat sini, tapi you have to derive a V for speed of satellite. So the only force acting toward the center of the circle is Fg. So Fg equal to mv squared over r. So you have Gm, m over r squared equal to mv squared over r. You can cancel of m. So then we have Gm equal to V squared R. Okay, so V squared equal to Gm over R. So we have V, which is set of Gm over R. Okay, so we have V, which is the satellite motion, is equal to velocity of satellite motion, Gm over R. So 6.67 times 10 power of negative 11. The mass of Earth is 6 times 10 power of 24, and the radius is the distance actually, plus 6.4 times 10 power of 6. Don't forget to put your square root. So velocity is 2699.93 meter per second. Okay, so this is your speed of your satellite. Okay, kita tengok pula nak cari period. Okay, nak cari period. So the period, okay, kita dah tahu dah kita punya formula for period, which is T is equal to 2 pi sine of R cube over Gm. So T is equal to 2 pi. Okay, your R is what? R tadi apa? R is equal to radius of Earth plus altitude. So 6.4, okay, times 10 power of 6 plus 350 times 10 power of 3. So 6.4 times 10 power of 6, 350 times 10 power of 3, okay, cube kan dia. Okay, tak nampak pula kat situ, saya tempat yang besar sikit lah. Okay, so T, okay, your T is equal to 2 pi set of R cube over Gm. Ingat T equal to 2 pi set of R cube over Gm. Okay, so ini yang B punya, yang betul. T equal to 2 pi set of R cube over Gm. So your T equal to 2 pi. Your R is 350 times 10 power of 3 plus 6.4 times 10 power of 6. Okay, so remember to put your bracket here, because it is power of 3 over G 67 times 10 power of negative 11, and your mass of earth is 6 times 10 power of 24. So then you have your period in second, which is 55508 seconds. Okay, and then for number 3, okay, the radial acceleration of the satellite. Kita ni kat sini, the radial acceleration of the satellite. Okay, so kita tengok the radial acceleration, which is number 3. So we have AC equal to mv squared over r. Oh no, AC is equal to v squared over r only. Okay, AC equal to v squared over r. AC is centripetal force. Okay, we can say radial. AC is centripetal acceleration, or we can say radial acceleration, which is AC equal to 37699.93 squared over R. R ingat tadi, R kita 350 times 10 power of 3 plus 6.4 times 10 power of 6. Okay, so you will have your AC, which is 8.784 meter per second square. Okay, so settle soalan untuk soalan yang pertama. Okay, soalan A dah settle. Soalan B. Okay, soalan B cakap apa? Figure shows a mass M1 is positioned between two masses. Okay, M2 is 40 kg and M3 is 60 kg. M2 and M3 is separated by 15 meters. Sketch and label the forces acting on mass M1. Okay, so bila soalan cakap acting on mass M1, so you punya forces, okay, mesti start daripada M1. So kita ada apa? F12, satu lagi kita ada F13. So this is the forces that acting on M1 due to M2 and M3. Okay, so settle. Number 2, determine X when M1 will experience zero net force. Okay, kita tengok soalan number 2. Alright, so for number 2, soalan B tu. Okay, so F net at M1 equal to 0. So kita tengok tadi dia punya forces macam ni kan. Okay, so this one is F113, F12. Okay, so kita tengok dia punya, saya lukis sikit lah. Okay, M1, M3, M2. Okay, distance between M2 and M3 is 15 meters, and then here M1 and M2 is X. Okay, so soalan cakap, F net at M1 equal to 0. So kat sini F13 minus, okay, kat sini ada forces F12, F13 minus F12 equal to 0. Because F net at M1 equal to 0, so F13 equal to F12. So we have G mass 1 mass 3 over R13 squared equal to G mass 1 mass 2 over R12 squared. Okay, 13 is distance between mass 1 and mass 3. R12 is distance from mass 1 to R2. So we can cancel of G, and then we can cancel of M. So we have M3, which is 60 kg. Okay, M3 is 60 kilogram in the question. No, M3 is 60 betul. M2 is 40 kilogram. So your M3 is 60. R13 1 and 3, so 60 R13 is 15 minus x square minus 140 over x square. So jarak kat sini, jarak kat sini x. So jarak kat sini mestilah, okey, jarak kat situ semestinya R13 ni mestilah 15 tolak x. Okey, sebab kat sini 15. Okey, so then kita mathematics process 40 over 60. So x over 15 over x equal to 40 over 60. Kita set lagi sebab kita hilangkan kuasa 2. So we have x equal over 15 minus x equal to 0.8165. So your x will be 6.74 meter. Okay, x is 6.74 meters. Okay, so macam tu lah. Okay, tengok jawapan ni pada tadi. Okay, 6.74 meters. Alright, so seterusnya kita akan tengok soalan nombor 2. Okay, soalan nombor 2. Given the mass and the radius of planet Mars are 6.42 times 10 power 22 kilogram and the radius of Mars is 3.4 times 10 power of 6 meters, calculate the gravitational acceleration on the surface of the planet. Okay, ingat on the surface of the planet. So number 2, given that mass Mars 6.42 times 10 power of 23 kilogram and radius Mars is 3.4 times 10 power of 6 meters. Okay, so to find the acceleration is the formula gm over r square. So we have a g constant. Mars is 6.42 times 10 power of 22 over the radius on the surface of the Mars 6 square. So your Ag is equal to 3.70 meter per second square. Okay, as simple as that. Okay, alright, so dah number 2. Okay, number 5A ni. Okay, number 5A ni sebenarnya sama saja dengan soalan mana? Soalan number 2 tadi. Same with number 2. Okay, number 5B. Derive the period of the satellite. Okay, so you have to derive the period of the satellite. So macam mana cara nak derive? Okay, kita tengok derivation for the period of the satellite. Okay, number 5B. Derivation period of satellite. Okay, daripada mana? Kita ingat daripada summation FC equal to mv squared over r. So the only force acting toward the center of the circle is Fg squared over r. So we have G m1 m2 over r squared equal to m2 v squared over r. So m2 ni is satellite lah. Satellite, m1 tu is a planet. Okay, so we can cancel of m2. So we have gm equal to v squared r. Okay, gm equal to v squared r. Okay, so v equal to gm over r. So macam kan. Okay, so ni untuk dapatkan velocity of the satellite. Okay, so kita tahu daripada v ni kita dapat r omega equal to set of gm over r. R omega equal to apa? 2 pi over t equal to set of gm over r. Okay, So kita tak nak set tu, kita kena kuasa 2 kan dia. Okay, so akan jadi kat sini R 2 pi over T equal to GM over R. So kita kuasa 2 kan. Okay, yang ni sebenarnya macam ni. So bila kita kuasa 2 kan, kita cancel lah. Okay, so kat sini kita akan ada 4 pi squared R squared over T squared equal to GM over R. So then, okay, sebab kat sini, so T squared GM equal to 4 pi squared R cube. So T squared equal to 4 pi squared, okay, R cube over GM. So T is 2 pi set of R cube over GM. Okay, so show that our T is equal to 2 pi set of R cube over GM. So ni untuk derivation kita. Alright, so untuk soalan B tadi nak apa? Mana tadi? Okay, ni pula. Calculate the distance from the center of the earth for a satellite to remain above the same location at the earth equator. The mass of the earth is given by 0.97 times 10 power of 24 kilogram. Okay, so kita tengok calculate the distance. Distance apa? Distance nak cari R lah. From the center of the earth for a satellite to remain above the same location of the earth equator. Okay, so same location in the earth equator ni, so maksudnya our T, okay, our T is same as the period for the earth is revolve 1 day equal to 24 hours. Period sama lah. Kita gunakan period yang sama dengan earth. Okay, so B2. Okay. B2. So T equal to 2 pi set of R cube over GM. So kita nak cari R kita nak cari R. So T squared equal to 4 pi squared R cube over GM. So R cube equal to T square GM over 4 pi square. So R cube equal to T square GM over 4 pi square set of 3. Macam tu. Okay. So kita nak dapatkan R cube. Okay. So R cube kita dapatkan R je. Okay. Sebab kita dah buat tadi kita dapatkan R. So equal to, okay, besar sikit, T kat sini is 1 day 24 hours 60 minutes 60 second 6.67 negative 11 mass is 5.97 times 10 power of 24 over 4 pi square. Okay, so you will have your R, which is 4.22 times 10 power of 7 meters. Okay, remember that this R is measured from apa? Okay, so ni Earth, kita punya satellite. Okay, so kita punya R tu, kita punya R is from ni, center of Earth. Ini radius of Earth. So R ini adalah radius of Earth plus dengan altitude. Okay. So kalau soalan cakap nak altitude saja, so H equal to R minus dengan R Earth. Okay, tapi soalan ni dia nak apa? Dia nak, okay, soalan ni dia nak, okay, dia nak tadi number 5. Okay, distance from the center of Earth. So maksudnya nak cari R lah ni, nak cari R saja. Okay, so seterusnya kita tengok number 8. Okay, number 8 kita cakap apa? A 800 kilogram satellite is orbiting the Earth at altitude, okay, 350 kilometers. The radius and the mass of Earth are given. Calculate the gravitational potential energy and speed and the orbiting period. Okay, kita tengok nombor 8A. Nombor 8A, kita tengok 8A. Okay, so the mass is 800 kilogram. The altitude is 350 kilometers. Radius Earth given is 6.4 times 10 power of 6 meters. And the mass of Earth given 5.98 times 10 power of 24 kilograms. Okay, so you have to find the gravitational potential energy where U is equal to negative GMM over R. So U negative G 6.67, negative 11. Mass Earth is 5.98 times 10 power of 24. The mass of object and the radius. Radius, ingat, radius is from the center of Earth. So radius of Earth 6.4 times 10 power of 6 tambah dengan 350 times 10 power of 3. Ni. Ini R kita ni. R is R Earth plus H. Okay. Ni. Radius of Earth, kalau satellite dekat sini, so tambah dengan H. Ini adalah kita punya R. Okay, ingat kat sini markah ni. So U is equal to negative 4.73 times 10 power of 10 joules. Alright, soalan yang kedua tadi nak cari apa? Soalan kedua kita nak dapatkan kita punya apa tadi? Kita punya speed. Okay, speed and orbiting period. Speed and orbiting period. So V is equal to GM over R. So jangan risau because the formula is given. Tapi you also have to do the derivation for V. Kalau soalan suruh cari derivation, so you kena derive lah. Tapi kalau soalan tak suruh, you guna saja apa yang dibagi. So V is equal to 6.67 negative 11 mass of Earth. Ingat, mass ini mesti mass of the planet. 5.98 times 10 power of 24 over 350 times 10 power of 3 plus 6.4 times 10 power of 6. And then don't forget to set. So 7.96 times 10 power of 3 meter per second. And the last one, you have to find the orbital speed, which is 2 pi sec of R cube over GM. So berhati-hati dalam you must substitute because nilai dia agak tinggi. So untuk you buat careless tu agak tinggi jugalah. 350 times 10 power of 3 times 10 power of 6. Okay, don't forget to put the bracket. 6.67 times 10 power of negative 11 times 10 power of 24. So you will have your T is 55.7.24 seconds. Okay, good luck and all the best.